So far, you as the programmer have added virtual walls to the robot's mental maze, so to speak, to allow us to test the algorithms that we've written so far and make sure that they're working. However, if we want the robot to navigate a maze all by itself, then we're going to have to come up with some routines that allow the robot to add walls all by itself when it comes across them. The first step in this process is to come up with a routine that allows us to add walls with respect to where the robot is at, given only the direction of that wall. So let's suppose we have a robot right here facing east. It would be very helpful if I had a function, let's call it addWalls. If I passed addWalls the information north, it would automatically draw a wall to the north. And if I were to call that function again and pass it the information east, it would draw a wall to the east. In order to implement this functionality, we're going to review one really important concept, and that is where the walls are located relative to the mouse. So we've actually already discussed this, but we're just going to refresh real quick. The cell here has the same coordinates, the same row and the same column as the north wall and the west wall. So the difference in rows and columns between the cell and the north wall and the west wall is 0 rows and 0 columns. 0 for here and here. However, the east wall is the same row, so its difference is 0 rows, but it's 1 column over, so plus 1 column. And the south wall is 1 row below the cell, and it's 0 columns over. So armed with this information, we're going to add one more function to our maze class. I'm going to add this function to the NanoMouse maze class right below the find best neighbor function and right above the add virtual walls function. I can go anywhere within the class, but I just want to put it right here. It's going to be add walls, and it's going to take one argument which represents the cardinal direction of the wall with respect to the mouse. So is it to the mouse's north, east, south, or west? To handle those 4 possibilities, I'm going to use a switch, and I will pass the switch the cardinal direction of the wall. And then I'm going to handle each case. So the north case, I want to modify the horizontal walls array, and I'm going to pass it the mouse row and the mouse column because the north wall's row and column has the same numbers as the cell in question. And by setting that equal to true, it adds a wall to the array. I'm going to now handle the east case. And so I will want to modify the vertical walls array. And because it's the east wall is in the same row as the cell in question, I don't need to modify the row, but I do need to modify the column. It's actually 1 column over, so I'm going to have to add 1. Just like I explained in the... Alright. Now, I'm going to leave the south and the west cases to you so that you can make sure that you have an understanding of what needs to change and why to make this function work. We can test what we have now by going to the setup part of the main program and switching add virtual walls to add walls. And I'm going to add a wall to the east. So the robot starts out in the lower left corner of a 4x6 maze, pointed north. Because I removed the add virtual walls line of code that was right here, there's not going to be any interior walls to this maze until we run this line, which is going to add a wall to the east of the mouse. And then it's going to solve the maze, and then it's going to print the maze. I actually don't need this line of code because I have no need to test the find best neighbor function anymore. By this point, it should be working well. Let's upload the program and run it. And here you can see the mouse in the lower left corner pointed north with a wall to its east. Once you think you have the addWalls function working, go ahead and change the mouse's position and heading at least a couple times and try adding walls to the north, east, south, and west to make sure that you have those 4 cases coded correctly.